Hey, welcome back. In this video, we're going to talk about a very important subject when it comes to programming video games and programs that involve time in general, and that's the subject of delta time. We're going to talk about how delta time is the time between frames and why that's important to us, particularly why we need to use it to accommodate for frame time variations. We're going to use delta time to keep our movement consistent even if that frame time varies from frame to frame. So let's get started. Now, in our program, we've been using the setTargetFPS function passing in 60. Now, so far as we understand, setTargetFPS will set the target frames per second, but what you might not have realized is setTargetFPS does not guarantee this value. That's because the processes performed by the CPU, or the computer's brain, cause strain that may slow down the frame rate. The more strain, the lower our frames per second. Here we have a graph labeling the x direction in meters. Now let's say we have Scarfy standing at 0 meters. Now, for simplicity's sake, I'm going to assume that we have a frame rate of 1 frame per second. Now let's also assume that Scarfy's moving along at a velocity of 1 meter per frame. So at 0 seconds, Scarfy starts off at 0 meters. Now since our frame rate is 1 frame per second, each second 1 frame passes by, which means that Scarfy moves along at a constant rate of 1 meter per second, and in 10 seconds, Scarfy will find himself 10 meters ahead. So far, so good. Now suppose that out of the blue, our frame time changes, and suddenly we get 2 frames per second. In other words, our game has just doubled the frame rate. Now if Scarfy has a velocity of 1 meter per frame, then Scarfy starts off at 0 seconds, but since we get 2 frames per second, then each second Scarfy gets to advance by a meter twice. So Scarfy will find himself 10 meters ahead only 5 seconds later. His perceived velocity, that which we see on the screen, appears to have doubled. This is what happens when we have a velocity in units of distance per frame. But suppose we had a velocity of 1 meter per second. In other words, our velocity is independent of frame rate. Well, then Scarfy could just coast along at 1 meter per second, and it doesn't matter what the frame rate is, Scarfy will still find himself 10 meters ahead in 10 seconds. Now, it'd be nice to have a velocity that's independent of frame rate, but we update the position every frame. So we have to add something every frame, but if we want it to be consistent, no matter how the frame rate varies, what exactly do we add? How much distance per frame do we advance Scarfy? This is where delta time comes in. Delta time is the time since the last frame. As our frames per second increase, delta time goes down. There's less time between frames as there are more frames in a given second. But as the frames per second go down, delta time increases. There are less frames in a given second, so the time between them is longer. So if we multiply velocity by delta time, then our velocity is scaled by the amount of time between frames. Now, Raylib has a function called getFrameTime. This is the delta time between frames. Here's how we would use it. Say we have a velocity of 1, and that's in pixels per frame. Now we use the velocity to move the position by 1 pixel each frame. But instead, say we want our velocity in pixels per second. If we want to move our position by 60 pixels per second, then we would get our delta time using getFrameTime and storing that in a float called dt. This gives us the time since the last frame. Now if we multiply velocity by delta time when we update the position, our velocity is scaled by delta time, so we're moving pos y by exactly the amount necessary for us to have a constant rate of 60 pixels per second. So here in our program, let's change gravity. Instead of 1 pixel per frame, let's give it a value of 1,000, and this will be pixels per second per second. This will be how many pixels per second we're going to increase the downward velocity per second. Remember, the apostrophe is ignored by the compiler. It's just used so we can separate those zeros and make this more readable to humans. Now, let's look at our jump velocity. We've been using pixels per frame, but we'd like to use pixels per second. Let's change this to a value of about 600, and in our comment, we'll say pixels per second. And now for your challenge. You're going to create a const float called dt for delta time. Go ahead and create it inside the while loop and initialize it with the value returned from getFrameTime. We're going to multiply by dt whenever updating the velocity when we apply gravity, as well as when we update the position when applying velocity. This way our movement will be independent of frame rate. Pause the video and do this now. Okay, so we're back in our program, and we've already changed gravity to have units of pixels per second, and our jump velocity is also in pixels per second. Now, since these are in units per time instead of per frame, now we need to use delta time. So we're going to go down into our while loop, and I'm going to make a comment saying delta time, and in parentheses, time since last frame. Now I'm going to make a const float called dt, standing for delta time, and I'm going to initialize it with getFrameTime. So we have delta time. Now let's go down to where we update velocity using the acceleration due to gravity. Gravity adds 1,000 meters per second to the velocity every second, but we're updating every frame, which means we need to multiply by delta time. Now also, we must go down to where we update the position. The position is updated by velocity, which currently has units of pixels per second. So we need to multiply by delta time, so velocity has units of pixels per frame, and it's scaled by the amount necessary to give scarfypos.y the exact amount necessary each frame so it's frame rate independent. Let's hit run and start debugging. Here's our window, here's Scarfy. I'm going to hit space to jump, and Scarfy jumps, and gravity pulls Scarfy back down, just as we expected. Now we've changed our values a bit, so gravity's working a bit differently, but of course if you want a stronger gravity, you can increase that amount that we're initializing gravity to. Okay, so in summary, we've learned about delta time and how delta time is the time between frames. We learned that we can get delta time by calling getFrameTime, a raylib function. We changed our gravity so that it has units of pixels per second, independent of frame time. We also changed our jump velocity to pixels per second as well. And we multiplied by delta time whenever we update our position using the velocity, and when we update velocity with acceleration. Now, no matter what the variations in frame rate may be, we'll get the velocity and acceleration we desire, and the behavior will be consistent, no matter how fast or slow the computer is. Excellent job. I'll see you in the next video.